My dear students, today we are going to discuss a new chapter called Basic Logic Gates. From this chapter we are getting 4 marks for the annual examination. One question will be from part A, that is one question will be asked for 1 mark and one question is coming from 3 mark question part C. Total we are getting 4 marks from this chapter. Last class we discussed Boolean algebra. In that chapter 2 topics are left, that is De Morgan's theorem as well as simplification of Boolean expression using K-map. So now today I am going to start this new chapter because to prove the De Morgan's theorem, there are 2 ways. One is using truth table as well as second way is nothing but using logic gates. So therefore we have to know what is the logic gate, what are the types of logic gates. That's why today I am going to take class on this basic logic gates. After completion of this chapter I am going to cover those 2 topics. A gate or logic gate can be defined as it is a simple electronic circuit which accepts 2 or more input signals to produce one output signal. We can say that a gate or logic gate can be defined as a simple electronic circuit which may have 2 or more input signals and one output signal. So now the logic gate can be classified into 2 types. First one is basic logic gate, second one is derived gates. What I said, a basic logic gate, or a gate is an electronic circuit which may have 2 or more input signal to produce one output signal. Okay, this logic gate can be classified into 2 types. First one is basic logic gate and another one is derived gates. Basic logic gate is nothing but fundamental logic gates are considered as basic logic gates. For example, AND, OR, NOT, AND or NOT. These are basic logic gates. Means fundamental gates are called basic logic gates. And the next one is derived gates. Derived gates. Derived gates is nothing but gates which are derived with the help of basic logic gates are considered as derived gates. Gates means gates which are derived means gates which are constructed with the help of logic gates, means AND or NOT. Such gates are called derived gates. For example, NAND gate, NOR gate, XOR gate, XNOR gate. Right? This XOR gate is also called exclusive OR gate. This XNOR gate is also called exclusive NOR gate. So here, what is a derived gate means? We can say that a gate which is constructed with the help of a basic gate is called a derived gate. It means, he says, NAND, NOR, XOR, XNOR are called derived gates. It means to construct these gates, we are going to take help of basic gates. Means these are not directly constructed. To construct an NAND gate or to construct any these derived gate means we are going to take help of any three basic gates. For example, to construct this NAND gate, we are going to use AND and NOT. Without AND and NOT, NAND is not possible. Like that, to construct NOR gate, we are going to use this OR gate as well as NOT gate. Without OR and NOT, NOR is not possible. Like that, any gate, you take any gate, to construct these gate, we need help of these basic gates. Hence, a derived gate can be defined as a gate which is constructed with the help of basic gate is considered as derived gates. So, now we discussed the definition of a logic gate, classification of logic gate. Now, let us see one by one in detail about all these gates. Consider first NAND gate. AND gate. This is the first one, first basic gate, AND gate. In the exam point of view, it is very important to know the definition of all these gates. For 1 mark, he is going to ask define NAND gate, NOR gate, OR gate, anything. As well as he is going to ask for 3 mark define. For example, define AND gate with truth table and logic diagram. For the definition 1 mark, for its truth table 1 mark, for its logic diagram also carries 1 mark. So now let us see what is mean by AND gate. So we can say that what is an AND gate? AND gate is one of the basic gate its output is high, means 1, its output is high if and only if all the inputs are low. In other case, its output is low. What is a NAND gate? NAND gate is one of the basic gate in which output is high if and only if both the inputs are high. In other case, output is low. So see here, truth table. Let us see first logic diagram of AND gate. This is nothing but AND gate. This is nothing but logic diagram. So from this diagram we can say that NAND gate is nothing but one of the basic gate which has 2 or more input, 1 output signal. Definition of gate. What is a gate? It is a simple basic electronic circuit which has 2 or more input, only 1 output. Right? That is the definition of gate. What is a NAND gate means? A NAND gate is a gate, basic logic gate, which has two or more input signal but produces output signal in such a way that in the output, when both the input are high, then only output is high. In other case maybe 0 0 0 1 1 0 like that. In other case, output will be low. So just to see the truth diagram, then you are going to get more confident on definition of this NAND gate. See here, this is nothing but two variable AND gate. This is nothing but two variable AND gate. We can draw three variable AND gate, four variable AND gate, like that, so on. What happening? Suppose we are taking another input means x, y, z means result will be x into y into z. See here, this is a two variable AND gate. That's why truth table for two variable NAND gate is see here x and y are nothing but input, right? X and y are nothing but input. This R is nothing but result, that is output, right? So how to construct a truth table means consider first input x and y are the input. Two variables are there, therefore how many combination means 2 power 2, 2 power n, 2 power 2, 4 combinations, 0 0 0 1 1 0 1 1. We discussed in the construction of truth table last class. Next, see the resultant expression. R is equal to resultant expression is equal to x into y, means 0 into 0 0, 0 into 1 0, 1 into 0 0, 1 into 0 0, 1 into 1 1. See here, this truth table, it is very easy to remember the definition of AND gate. What I said, in the AND gate is one of the basic logic gate in which result is high. See here, 1, result is high if and only if both the inputs are high. See here, result is high means 1 if and only if both the inputs are high. In other case, low, that is 0 0 0. From the truth table also, it is easy to define AND gate. So we can say that AND gate is one of the basic logic gate in which output is high if and only if both the inputs are high. In other case, output is low. Here, this AND gate can be symbolized as x and y is equal to, symbolized means how we can write here x and y are the two input. These two inputs are goes through AND gate, means we can write x and y can be symbolized as x into y. See a resultant x into y. So this logical multiplication indicates AND gate operation, right? So how we can define AND gate? AND gate is one of the simple basic gate in which result is high if and only if both the inputs are high. In other case, result is low. So this is possible for two variable as well as three variable input AND gate. So in the examination, he is going to ask for 3 marks. Define AND gate with its truth table and logic diagram. So we have to draw like this logic diagram and like this truth table, as well as we have to define this AND gate in a simple way. That is, AND gate is one of the basic logic gate in which output is high if and only if both the inputs are high. In other case, output is 0, or else we can say low. So here, observe here, input I taken the 2 variables. You can take any 2 variable, that they may be A or B, X, Y, M, N, like this. But we are going to consider here 2 variables as X and Y, means in the resultant expression we have to write X into Y only. Don't write here A into B. We are taking input as X into Y, means output must be X into Y. Here what variables we are taking in the input side, those must be considered in the resultant expression, that is output side. So see the next logic diagram, that is, see here, AND is over. Second one, OR gate. This OR gate can be defined as, it is also one of the basic gate in which output is low. Output is low if and only if both the inputs are low. In other case, output is high. For example, see here, logic diagram means logic diagram for OR gate, truth table for OR gate. See here, logic diagram means this is OR gate, that's why we have to write inside OR. Resultant expression is X plus Y. See here, these two are the inputs. In the input side, we take another X into Y. Therefore, resultant expression is X plus Y. So this OR can be symbolized as X or Y is equal to X plus Y. X plus Y means plus is nothing but OR gate operator, right? So now write the truth table for OR gate. X and Y are the inputs. Resultant expression R is equal to X plus Y. So 2 variable means 0, 0, 0, 1, 1, 0, 1, 1. So what is the definition of OR gate? OR gate is one of the basic logic gate in which output is 0. Output means R. Resultant expression. Output is 0 if and only if both the inputs are 0. Output is 0 if and only if both the inputs are 0. In other case, output is 1. See here. This definition can be verified using truth table also. See here, X and Y are the two inputs. Resultant expression equal to X plus Y means perform logical operation here. Addition 0 plus 0, 0, 0 plus 1, 1, 1 plus 0, 1, 1 plus 1, 1. Because we are using logical operations, means we have to use only Boolean values. That's why 1 plus 1 1. We discussed in the last chapter, right? So here this is nothing but truth table. Now check the definition of OR gate. This OR gate is one of the simple basic gate in which output is low if and only if all the inputs are low, right? In other case output is high. In other case means 0 1 1 0 1 1, it may be anything. So we have to remember this thing to define OR gate. How to remember this table? For that AND gate we have to remember this thing. In the AND gate result is high if and only if both the inputs are high. In other case output is low. Like that in OR gate, see the truth table and define. In OR gate result is means output is low when both the inputs are low. In other case result is high. Like that, by seeing truth table we can also define definition of each gate. Now AND gate is over, OR gate is over, and the next one is NOT gate. NOT gate. NOT gate. It is also called inverter. NOT gate is also called inverter gate. It is very, very important because NOT gate is a one basic gate. We can say it is a special gate because it has only one input and only one output signal. Except NOT gate, you consider any logic gate which may have two or more input signal, one output signal. But NOT is a special gate. NOT gate is also called an inverter. It is called a special gate because it has only one input and one output signal. So we can define as NOT gate is one of the basic gate which has only one input signal and one output signal, and it produces high or 1 when input is low, and it produces low means result is low when input is high. Reciprocal. If input is high means output is low. If input is low means output is high. So take the logic diagram. Logic diagram of NOT gate. Consider truth table of NOT gate. First see the logic diagram. It is a special gate because it has only input. That's why only one input. That's why if X is the input mean resultant expression, this is NOT gate, right here NOT, resultant expression R is equal to X bar. Means in the definition I said if input is high means output must be low. If output is input is high means output must be low. If input is low means output must be high. That is reciprocal. So that's why here variable X is there means resultant expression is going to be X bar. So this is what logic diagram of NOT gate. Now see the truth table. Only one input is there, therefore 2 power n, 2 power 1 equal to 2 input combinations will be there for the truth table. That's why see here, if X is the input means resultant expression R is equal to X bar, right? So one input is there means 2 power 1 means two input combination means x value may be 0 or 1, right? X value may be 0 or 1. If x value 0 means output is complement of x means 1. If x value 1 means output is complement of x means 0. That's why we can say that NOT is one of the basic gate in which output is high if input is 0. Output is low if input is 1. That is, a NOT gate is one of the basic gate in which output is invert, or we can say output is complement of input. Means if input 0, output is complement means 0 complement means 1. If input is 1 means 1 complement is 0. Like this we can define NOT gate, right? So it is very important. NOT gate is a special gate, you can say special gate, because it has only one input signal and one output signal. Except NOT gate, all the gates are going to have 2 or more inputs, but NOT has only one input signal. So these are what definition, truth table, and a logic diagram of basic gates. And this NOT of x can be symbolized as x bar, right? Means if x is a variable, when it undergoes through NOT operation, NOT gate, we get x bar. So like this x and y are two input variables, where these two are passed through OR gate, then we get x plus y. This OR gate can be symbolized as x plus y. NOT gate can be symbolized as x bar. Like this, AND gate can be symbolized as x into y. Right? So now basic gates are over. Let us discuss derived gates. Derived gate. What I said? Derived gates are nothing but gates which are constructed with the help of basic gate. For example, NAND gate, NOR gate, XOR gate, XNOR gate. These 4 are called derived gates, because to construct these gates we are going to take the help of basic gates. Gates which are constructed with the help of basic gates like AND or NOT are called derived gates. Now see the first one. Consider first one, NAND gate. NAND gate, its logic diagram is this is nothing but NAND gate, two variables x and y. So this NAND gate is constructed with the help of AND gate and NOT gate. That's why we have to put here bubble. Then it works as NOT gate. Then we get result is equal to, you see, AND gate means x plus y. This is NAND gate, means here NOT gate is there. That's why it becomes AND means X into Y. Here NOT is there. That's why it becomes X into Y whole bar. X into Y whole bar. See here, X NAND X NAND Y can be symbolized as X into Y whole bar. Right? Now see here, it's a truth table. X, Y are the two inputs. Resultant expression is equal to X into Y whole bar. Right? So two input means four combinations: 0, 0, 0, 1, 1, 0, 1, 1. Right? 0, 0, 0, 1, 1, 0, 1, 1. See here, perform X into Y whole bar. What happens? 0 into 0, 0. 0 bar means 1. 0 into 1, 0. 0 bar means 1. 1 into 0, 0. 0 bar means 1. 1 into 1. 1 bar means 0. See here. Now how to define NAND gate? You compare this NAND gate with AND gate. AND gate output is 0, 0, 0, 1. NAND gate output is 1, 1, 1, 0. That is, output is complement of AND gate. Means NAND gate output is complement of AND gate. So that's why we can say that NAND gate is constructed with the help of AND gate and NOT gate. So now we can define this NAND gate as, consider this unique value. In the NAND gate, output is low when both the inputs are high. NAND gate can be defined as, is one of the derived gate in a bit. Output is low when both the inputs are high. In other case, output is high. Right? And we can say that in the NAND gate, resultant expression is X into Y whole bar. Whereas in AND, only X into Y. Here, X into Y whole bar means AND gate result is complemented. So we can say that NAND gate is a complement of AND gate. NAND gate result is obtained by complementing AND gate resultant expression. Right? Now consider second derived gate, that is NOR gate. NOR gate. By seeing the name only, we can say that this NOR gate is constructed with the help of OR gate and NOT gate. Right? So see its logic diagram. NOR gate. So NOR gate is constructed with the help of OR gate and NOT gate, right? So first write OR gate. X and Y are input means OR means like this only. But NOR gate is constructed considering OR gate and NOT gate. That's why we have to take here bubble. If bubble is not there means we get X plus Y. Bubble is there, that's why resultant expression become X plus Y whole bar. Right? So now consider its truth table. Truth table for NOR truth table for NOR gate. X and Y are the inputs. Resultant expression is equal to x into y whole bar. Right? Resultant expression is equal to x plus y whole bar, because r is there, plus x plus y whole bar. Two variables means four combinations: 0 0, 0 1, 1 0, 1 1. Right? So write the result: x plus y whole bar. 0 plus 0 0, 0 bar 1, 0 plus 1 1, 1 bar 0, 0 plus 1 1, 1 bar 0, 1 plus 1 1, 1 bar 0. See here, resultant expression. Compare the NOR gate resultant expression with the OR gate. What we can say, in the OR gate we get 0 1 1 1. Here their resultant expression is x plus y, we get 0 1 1 1. Here resultant expression is x plus y whole bar, means the result is complemented. That's why what we must get, 1 0 0 0. Right? See here, 1 0 0 0. That is, in the OR gate x plus y is there, that's why we get 0 1 1 1. Here NOR x plus y bar is there, that is complemented, that's why we get 1 0 0 0. We can say that NOR gate is a complement of OR gate. NAND gate is a complement of AND gate. So how to define a NOR gate? See once again. In the NOR gate, we can say, in the NOR gate, a result is high 1 if and if both the inputs are low. In other case, result is low. Like this, we can define NOR gate. Right? Now consider next, fourth, XOR gate. XOR gate. So first see the logic diagram of XOR gate. This is also called exclusive OR gate. XOR gate. See here, this is what XOR gate means. Here for the OR gate we get another curve here, then it becomes XOR gate, and the resultant expression is X. This is called OR gate means X plus Y. XOR gate means X plus over circle Y. This plus over circle indicate OR operation. So X XOR Y can be summarized as X plus over circle Y. Like this we can write XOR expression. Now see the truth table. So what is XOR gate means? We can say that XOR gate is one of the derived gate in which result is high for odd number of ones. See here, result is high for odd number of ones. Means in XOR gate result is high when result is high for only odd number of ones in the input combination. See, X and Y are the input combination. If in the input combination column odd numbers are there means then only result is high. See here result is high because odd number of 1 is present. Odd number of ones means in the input side, input combination case, 1 must be counted for odd number of times. See here, these two are the inputs. 1 is there 1 time. Here is also 1 is there 1 time. It may be 1 time, 3 times, 5 times for 5 input combinations. Like that, in XOR gate result is high means 1 if and only if for the odd number of ones combination. Odd number of ones combination. Here 1 present 1 time. Therefore odd time. Therefore output is 1. Here also input 1 comes 1 time, odd time. That's why result is high. In other case result is low. Result is low. In other case means 1 must be even. Here 1 input 1 means 1 comes 2 times. Therefore low. Here 1 is not at all there. It is not there for even time as well as odd time. Therefore in other case means it is one of the other case. Therefore here also result is 0. Right? How we can define XOR gate? XOR gate is one of the derived gate in which output is high for odd number of ones. In other case output is 0. Like this we can define XOR gate. In the exam he may be asked, write the logic diagram, truth table and define XOR gate. Like this he can ask. For the logic diagram 1 marks. For the truth table, this is what? Truth table. Truth table for XOR gate. For the truth table also 1 mark. And for defining XOR gate, we get another mark. Like this, in the examination, he is going to ask such questions for 3 marks. For definition 1 mark, logic diagram 1 mark, truth table 1 mark. Now the remaining gate is XNOR gate. This XNOR gate. See, XNOR gate is nothing but complement of XOR gate. See here. First see the logic diagram. XNOR gate. This is nothing but complement of XOR gate. So this is what? 2 inputs. This is complement XNOR gate is complement of XOR gate. So this is what? XOR gate. We must get XNOR means for this XOR gate we have tried one bubble, then it becomes complemented. So its resultant expression is R is equal to X dot over circle Y. Right? So XOR gate is plus over circle. XNOR is nothing but dot over circle. So this can be represented as X and Y when undergoes XNOR operation, we can write X and Y are undergoes XNOR gate, undergoes on XNOR gate, we get X dot over circle Y. This can be XNOR gate can be summarized as like this. Now see the truth table. X and Y are inputs, resultant expression is equal to X dot over circle Y. So two variables are there, means 4 combinations 0 0 0 1 1 0 1 1. So here XNOR gate is a what? Complement of XOR gate. So their result is 0 1 1 0. Here 1 0 0 1. See here. Otherwise we can also define XNOR gate. We can define it. It is one of the derived gate. It is one of the derived gate in which, see here, in which output is low. Output is low for odd number of ones. Odd number of ones, output is low. In other case, output is high. Just XNOR gate is complement of XOR gate, right? What we said, what I said in XOR gate, output is high for odd number of ones. This is what XOR gate. XNOR gate complement of XOR gate. Therefore, here output is high means here output becomes low. Output becomes low. When say for odd number of ones, odd number of ones, output is low. In other case, output is high. Right? So what we discussed right now, we discussed logic gate, definition of logic gate, or simply you can say gate. A gate or logic gate is a simple electronic circuit which accepts 2 or more input signals but produce only one output signal, except NOT gate, right? So these gates can be classified into basic gates as well as derived gates. Basic gates is nothing but fundamental gates are considered as basic gates. For example, AND or NOT are called basic gates. Next topic, derived gate. Derived gate is nothing but a gate is constructed, a gate which is constructed with the help of basic gate is called derived gate. For example, NAND, NOR, XOR, XNOR, these are called derived gates. So we discussed these things in this class. In the examination, for 1 mark purpose, he is going to ask question, define NOR gate, define AND gate. Like this, any gate definition is asked for 1 mark, and for 3 mark, he is going to ask define a gate, means define, for example, define AND gate with its logic diagram and truth table. For the definition, we get 1 marks. For the logic diagram, we get 1 marks. For the truth table, also we get 1 marks. So this is what introduction to gates. In the next class, we are going to see universal gates in the next class. Thank you.